Parts of the aircraft. The parts of the aircraft are fuselage, wing, empennage, aircraft engine, landing gear, propulsion, cockpit, and control surfaces. First, we will see the fuselage. Fuselage. The picture shown is the fuselage of a Boeing 737 shown in brown. The fuselage, from the French fuselier, spindle shaped, is an aircraft's main body section. It holds crew, passengers, and cargo. In single engine aircraft, it will usually contain an engine as well, although in some amphibious aircraft, the single engine is mounted on a pylon attached to the fuselage, which in turn is used as a floating hull. The fuselage also serves to position, control, and stabilization surfaces in specific relationship to lifting surfaces, which is required for aircraft stability and maneuverability. The fuselage is used for fixing the wings and tail assembly. The fuselage is attached to the wings and tail assembly. The elevators and the rudders all attached to this fuselage section. There are different types of fuselage structures used in the previous aircraft and in the future applications. They are truss structure, geodesic construction, monocoque shell, semimonocoque. First we will see the truss structure. The picture shown is the Piper PA-18 aircraft's welded tube truss fuselage structure. Truss structure means this type of structure is still in use in many lightweight aircraft using welded steel tube trusses. A box truss fuselage structure can also be built out of wood, often covered with plywood. Simple box structures may be rounded by the addition of supported lightweight stringers, allowing the fabric covering to form a more aerodynamic shape or one more pleasing to the eye. Geodesic construction. The picture shown is the geodesic airframe fuselage structure is exposed by battle damage. It is the aircraft damaged by the during war. The tail section of the fuselage is damaged. Geodesic structural elements were used by Barnes Wallis for British Vickers between the wars and into World War II to form the whole of the fuselage, including its aerodynamic shape. In this type of construction, multiple flat strip stringers are wound about the former in opposite spiral directions, forming a basket-like appearance. This proved to be light, strong, and rigid, and had the advantage of being made almost entirely of wood. A similar construction using aluminum alloy was used in the Vickers Warwick with less materials than would be required for other structural types. The geodesic structure is also redundant and so can survive localized damage without catastrophic failure. A fabric covering over the structure completed the aerodynamic shell. See the Vickers Wellington for an example of a large warplane which uses this process. The logic evolution of this is the creation of fuselages using molded plywood, in which multiple sheets are laid with the grain in differing directions to give the monocoque type below. In general, the structure means the arrangement of and relationship between the parts or elements of something complex. A building or other object constructed from several parts. The station is a magnificent structure and should not be demolished. It is in the verb form construct or arrange according to a plan, giving a pattern or organization to. There are 4 types of structures: frame, shell, solid, liquid. Frame made of separate members, usually thin pieces put together. Shell encloses or contains its contents. Solid mass made almost entirely of matter. Liquid fluid, braking fluid making the brakes. Structures can further classified in number of ways. type solid. One dimensional, two dimensional, three dimensional, composite. One dimensional means ropes, cables, struts, columns, beams, arches. Two dimensional means membranes, plates, slabs, shells, walls, domes, synclastic, anticlastic. Three dimensional means solid masses. Composite, a combination of the above. One dimensional, two dimensional, three dimensional combination is the composite structure. What is a structure in technology? A structure is a group of elements somehow united to support a load with stability. Examples of structures are bridges, electricity pylons, or dams. Flexibility structures are often more able to withstand dynamic forces. Monocoque shell. This is one of the type of the structures used in aircraft. The picture shown is the Vance aircraft RV-7 of semi-monocoque construction. In this method, the exterior surface of the fuselage is also the primary structure. A typical early form of this, see the Lockheed Vega, was built using molded plywood, where the layers of plywood are formed over a plug or within a mold. A later form of this structure uses fiberglass cloth impregnated with polyester or epoxy resin instead of plywood as the skin. A simple form of this used in some amateur built aircraft uses rigid expanded foam plastic as the core with a fiberglass covering, eliminating the necessity of fabricating molds but requiring more effort in finishing. An example of a larger molded plywood aircraft is the de Havilland Mosquito Fighter light bomber of World War II. No plywood skin fuselage is truly monocoque, since stiffening elements are incorporated into the structure to carry concentrated loads that would otherwise buckle the thin skin. The use of molded fiberglass using negative female molds, which give a nearly finished product, is prevalent in serious production of many modern sailplanes. The use of molded composites for fuselage structure is being extended to large passenger aircraft such as the Boeing 787 Dreamliner, using pressure molding on female molds. Actually, in the today's aviation industries, the aircrafts are made up of composite materials. Mostly they use composites for the structure of fuselages and some wing sections. Semi-monocoque type of structure. The picture shown is the section the fuselage, showing frames, stringers, and skin, all made of aluminium. Aluminium is also one of the material used in the aircraft structure construction, in fuselages and also in the wing and tail assemblies. Actually, the aluminium is some kind of aluminium, not the original aluminium. It is a dura aluminium. It is a kind of dura aluminium material used in the construction of the aircraft, but this is replaced by the composite structures. This is the preferred method of constructing an all aluminum fuselage. First, a series of frames in the shape of the fuselage cross sections are held in position on a rigid fixture. These frames are then joined with lightweight longitudinal elements called stringers. These are in turn covered with a skin of sheet aluminum attached by riveting or by bonding with special adhesives. The fixture is then disassembled and removed from the completed fuselage shell, which is then fitted out with wiring controls and interior equipment such as seats and luggage bins. Most modern large aircraft are built using this technique, but use several large sections constructed in this fashion, which are then joined with the fasteners to form the completed fuselage. As the accuracy of the final product is determined largely by the costly fixture, this form is suitable for serious production where a large number of identical aircraft are to be produced. Early examples of this type include the Dufflos aircraft DC-2 and DC-3 civil aircraft and the Boeing B-17 flying fortress. Most metal light aircraft are constructed using this process. Both monocoque and semi-monocoque are referred to as trussed skin structures, as all are a portion of the external load, that is from wings and empennage, and from discrete masses such as the engine, is taken by the surface covering. In addition, all the load from internal pressurization is carried as skin tension by this external skin. The proportioning of loads between the components is design choice, dictated largely by the dimension, strength, and elasticity of the components available for construction, whether or not a design is intended to be self-jigging, not requiring a complete fixture for alignment. According to Federal Aviation Administration's definitions, the fuselage structure is classified as the fuselage is the central body of an aeroplane and is designed to accommodate the crew, passengers, and cargo. It also provides the structural connection for the wings and tail assembly. Older types of aircraft design utilized an open truss structure constructed of wood, steel, or aluminum tubing. The most popular type of fuselage structure used in today's aircraft are the monocoque, French for shingle shell, and semimonocoque. These structural types are discussed in more detail under aircraft construction later in the chapter. The types of aircraft construction. The construction of aircraft fuselages evolved from the early wood truss structural arrangements to monocoque shell structures to the current semi-monocoque shell structures. Truss structure. The main drawback of truss structure is its lack of a streamlined shape. In this construction method, lengths of tubings called longerons are welded in place to form a well-braced framework. Vertical and horizontal struts are welded to the longerons, give the structure a square or rectangular shape when viewed from the end. Additional struts are needed to resist stress that can come from any direction. Stringers and bulkheads or formers are added to shape the fuselage and support the covering. As technology progressed, aircraft designers began to enclose the truss members to streamline the airplane and improve performance. This was originally accomplished with cloth fabric, which eventually gave way to lightweight metals such as aluminum. In some cases, the outside skin can support all or a major portion of the flight loads. Most modern aircraft use a form of these truss skin structures known as monocoque or semi-monocoque construction. The semi-monocoque and monocoque structures are explained in these figures. Figure 2 to 14. Semi-monocoque and monocoque fuselage design. It is like cone structure. It consists of skin, formers. The lines, the ring is the former, and the skin is the outside structure, and the stringers are the small lines are going inside outside the ring. Outside the ring is the stringers that gives the strength to the same monocoque design. Bulkhead is the closing part, finishing part of the stringers and formers and the skin. Monocoque design is shown. In the monocoque, stringers are not available. Only the formers, ring-like formers, and the stressed skin. Skin is stressed into the formers, and the bulkhead is available. Semi-monocoque is more strengther than the monocoque. Monocoque construction uses stressed skin to support almost all loads, much like an aluminum beverage can. Although very strong, monocoque construction is not highly tolerant to deformation of the surface. For example, an aluminum beverage can supports considerable forces at the ends of the can, but if the side of the can is deformed slightly while supporting a load, it collapses easily. Because most twisting and bending stresses are carried by the external skin rather than by an open framework, the need for internal bracing was eliminated or reduced, saving weight and maximizing space. One of the notable and innovative methods for using monocoque construction was employed by Jack Northrop. In 1918, he devised a new way to construct a monocoque fuselage used for the Lockheed S-1 Racer. The technique utilized two molded plywood half shells that were glued together around wooden hoops or stringers. To construct the half shells, rather than gluing many strips of plywood over a form, 3 large sets of spruce strips were soaked with glue and laid in a semicircular concrete mold that looked like a bathtub. Then, under a tightly clamped lid, a rubber balloon was inflated in the cavity to press the plywood against the mold. 24 hours later, the smooth half shell was ready to be joined to another to create the fuselage. The two halves were each less than a quarter-inch thick. Although employed in the early aviation period, monocoque construction would not re-emerge for several decades due to the complexities involved. Everyday examples of monocoque construction can be found in automobile manufacturing, where the unibody is considered standard in manufacturing. The FAA's definition of semimonocoque is semimonocoque construction, partial or one-half uses a substructure to which the aircraft skin is attached. The substructure, which consists of bulkhead or formers of various sizes stridges, reinforces the stretched skin by taking some of the bending stress from the fuselage. The main section of the fuselage also includes wing attachment points and a firewall. On single-engine airplanes, the engine is usually attached to the front of the fuselage. There is a fireproof partition between the rear of the engine and the flight deck or cabin to protect the pilot and passengers from accidental engine fires. This partition is called a firewall and is usually made of heat-resistant materials such as stainless steel. However, a new emerging process of construction is the integration of composites or aircrafts made entirely of composites.